I recently inspected this Seth Thomas ship's bell clock. Mainsprings have been restrained and visible pivot locations with excess of wear have been marked. To prevent damage to the balance and hairspring, it'll be removed first. Loosen the cone bearing. Dried oil deposits adhering to the cone pivots. Inspecting the pivot ends, they're worn and rounded off from years of use. Remove some of this crusted deposit. Now the wear can be seen better. I'll recondition the pivot ends later. Ratchet wheel retainer clip, ratchet wheel, minute wheel retainer pin and washer, hour wheel, minute wheel, cannon pinion. Someone has used a center punch to smash and distort the brass around the center wheel pinion. A lot of wear here. It'll need a bushing installed to fix it correctly. Taper pins, bell hammers, rear plate pillar screws. Seth Thomas added a fifth pillar to this model to make it more rigid. Hammer arbors, pallet, escape wheel, fourth wheel, time side main wheel assembly, third wheel. Center wheel has a bent tooth. Usually happens when the mainspring breaks or was released too fast. A good way to straighten a tooth like this is to use a bending tool. I fabricated this tool out of aluminum. I chose aluminum because it's softer than the brass and won't damage or leave any tool marks on the tooth. Just takes a little time and it can be slowly pulled into position. The leading edge has a nick on it here. Each tooth has slight wear, but it's serviceable. This nick has created a burr on the working surface of the tooth. That can be honed off. Pivot on this wheel needs polishing. End of the pivot has been butchered. The center punch used to deform the brass around it has damaged the pivot. I'll need to cut the damage off before polishing. Rough shape it with an Arkansas stone. What's left of the nicks is in a non-working surface area of the pivot, so all is good on this one. Several defect items can be seen around this pivot hole location. The original oil sink has been smashed flat. Someone used a center punch to deform the brass around the pivot location, and someone has damaged the gold plating with this scratch mark. All workmanship issues, signs of a butcher. This is what the oil sink should look like. It can clearly be seen someone has smashed this one flat, then used a center punch to deform the brass. The hole is now most likely mislocated slightly from its original location, and after all the butchery, it's still egg-shaped. It will need to be pulled to the side to recenter it before a bushing is installed. I'll use the reamer technique to pull the hole to center instead of a file. Rotating the reamer 180 degrees, it'll cut one side of the hole until it's centered. Then finish with 360 rotations to bring the hole to finished size. Looking good. An air bellow works good to test for its freedom. Time side main wheel needs some attention. A failed repair attempt to the mainspring support brace can be seen. Take a closer look at it. Acid flux was used when applying solder and not cleaned off. The acid has eaten into the brass. Rosin flux should always be used when soldering brass to brass. More corrosion in this location, all from a small drop of acid flux that didn't get cleaned off. Mainspring support brace broke completely off on this side. These teeth have slight wear on them. As the wheel is rotated, it can be seen the wear is heavier on one side of the wheel than the other. Better than 50% wear on the teeth here, and an arrow scratched through the gold plating into the brass. Uneven wear on teeth of a gear like this is from it not running on true center. And back to the side with the least amount of wear. A copper-colored bushing was installed sometime in the past here. Arbor fits good. It's in fair shape, very little wear. Some solder has been applied here also. Maybe it was soldered in. Looking inside the bore, the bushing isn't long enough to reach the other side like it should be. There's heavy grease deposits where the short bushing ends inside. Looking on the other side, someone neglected to install a long enough bushing as should have been done. They left all the egg-shaped wear on this side. This condition causes the wheel to tilt and bind at the installed short bushing location. This egg-shaped hole is the root cause for the uneven tooth wear on the wheel. All the used wheels available for these movements are worn out, just like this one, so time to fabricate a new wheel. I'll fabricate a cutter using this high-speed steel lathe cutter blank. To get the profile transferred to the cutter, I'll start by centering a tooth with the arbor hole in the wheel. Rough scribe the tooth profile. Now that it's roughed out, it's time to hone the top on a fine Arkansas stone. Now to cut it more slowly to get a perfect fit. To complete the radius, I'll use a copper lap charged with diamond paste. The copper lap has the correct radius cut on it. Serrations need to be added to hold the diamond cutting compound. Apply some 1200 grit diamond paste, some oil, and it's ready to final form the radius. A final hone to the top surface. Hone the inner cutting edge. Final fit check. Perfect. C360 clock brass for the new wheel. Make a template to rough cut the new wheel. With the cutter mounted in the cross slide tool, I'll be using a process called shaping the teeth instead of cutting them. Advantage is it's quick to set up and works well for a one-off item. I don't get into mass producing gears and pinions, so this process has always worked well for my needs. Shave several thousandths with each pass. And now for the final tooth. They look nice. Fabricate the center arbor bushing. I made the new wheel close to double the thickness. It's a deviation from the original design thickness, but all of these I have seen have worn teeth, an improvement that the original designers would probably agree with to prevent premature tooth wear. New center arbor bushing fits up to the wheel nicely. Arbor fits perfect. Original has 5 spokes. I could leave the new wheel solid, but the client wants it to be crossed out, same as original. Draw file the edges smooth. I see a lot of these mainspring supports that are bent and broken. Another weak defective design flaw in these. Here you can see where the mainspring edge has scored the brass. Eventually, a stress crack will appear in the brass and they end up breaking. Most likely what happened to this support. I'll be modifying the original braces to improve their strength, using steel instead of brass. They'll be much more solid and less prone to fatigue like the brass ones. It's an issue of safety. The old wheel can be kept with the clock for originality. These should work just fine. This anvil will work perfect for shaping the radius. Looking good so far. Swage the center arbor bushing in place. Old wheel has its issues, as pointed out earlier. New wheel is more robust and should last longer in service. Rim is much wider. Mainspring support brackets are made from steel that is thicker than the original thin brass ones. New wheel is close to twice the thickness. These old original support brackets are prone to failing. New teeth look great compared to the old ones. Time to set the strike wheel up for assembly. It's quite easy. Find the side with 6 long pins next to each other. Back up 2 teeth and line it up with the 1 o'clock position of the count wheel. I find securing the 2 wheels with some soft copper wire works well. Someone has defaced the wheel here with a scratch in the past where it needs to be aligned. This tooth needs to be clocked with the deep cut in the count wheel. The count lever needs to be clocked to the low spot of the 3rd wheel cam. Looking good. Ratchet wheel. The new ratchet wheel fits to the click nicely. Seems to have good power to the pallet. Should be a strong runner. Balance has excellent motion now. Silvering on the dial is failing in areas, mainly where people's fingers have rubbed on it from using the key over the years. This mechanism for advancing the strike is in the way of reconditioning the dial correctly. These 3 rivets will need to be removed so the dial can be separated. Up close, the damaged silvering can be seen better. Exposed brass has oxidized. Heads of the rivets have flat surfaces on them left over from the install process. Finish on the dial is in a circular brushed finish. Around the keyholes, the brushed finish has been worn off and is now smooth. The brush finish will need to be restored in these areas before it can be resilvered. Black paint in the recessed numbers also needs to be touched up. Up close, it shows nearly 50% of silver loss. I'll see what can be done to remove these rivets without damaging the dial and dial pan. This tool will mark the center of the rivet for removal. Now that the center is marked, I'll use this reamer to slowly reduce the size of the squeezed shank. With most of the material removed from all 3 rivets, remove a little more by hand. This paper will protect the dial during removal. Perfect! No damage to dial or dial pan. Degrease it using detergent. This will restore the brush finish with minimal material loss. Looking good so far. Dial has been silvered. Now a final clean. Silvering looks great. Touch up the black in the numbers. Correct size of rivets aren't available, so time to fabricate the 3 dial rivets. These will work just fine. Dial looks much better. Time to rivet it back to the dial pan. They fit nice and snug. Some paper to protect the dial and face of rivet. This one could use a little more squeeze out. Movement is running nice and strong. Install the bell. A nice running Seth Thomas Model 7 ship's bell with an 1879 movement.